Hi, everyone. My name is Aaron Smith. I'm the CEO of EBA. I'm joined by Nancy Bateman and our longtime friend who needs no introduction. Sam, I don't know why I bothered to introduce you, but I've often said to you, Sam, that one of the blessings of the position that I have at EBA is getting to spend time with my heroes. And those of you that haven't been through the Housing 2.0 webinar series, I've gotten to attend it alongside Sam and many, many builders. It is an incredible series. And Sam will be at the EBA Summit coming up. If you haven't ordered the book yet, please go on Amazon and order it. But it's just amazing. I've heard it a couple times now. Every time I've got my notebook here, I come out with some new ideas, some fresh ideas. It's just such great, I'm going to call it disruptive thinking, Sam. So I'm so thankful that you're here today and that you'll be at the summit in September. But this is a question I always ask when I came into EBA. I was like, what is a high performance home? Like, how are we defining it? So I'm keen to understand that today. And then how to consistently deliver it at lower cost. And that's the really amazing part that you bring together, I think, Sam, is when we think about it holistically, we can deliver this at lower cost by carefully looking at those trade-offs. So we're an EBA, we're a Zoom webinar on the EBA platform. We have a Q&A section. I'll be curating those questions to Sam throughout the presentation. We'll leave some time at the end for additional questions. But Sam, with that, I'll turn it over to you and just welcome everyone.
Hey, thanks so much, Aaron, for such a generous introduction, as always. Always love working with you and Nancy and EBA in general. So this has just been a delight to do this series. This is the third webinar we've done. The first, we focus on the future of housing with certainty and try to give context for where things are going. In the second, and particularly, we also set a kind of a foundation for the importance of user experience. And then in the second webinar, excuse me, we focus on optimizing the design user experience. And we did that intentionally because we have to remember home buyers are infatuated with design, and you have to get design right. And there's a consistent framework for how we can do that. We introduced that in the second webinar. And now in the third webinar, you all are coming from EBA, who have a tremendous disposition to and focus in high performance. So I thought this would be a good way to wrap up the series on what is high performance. See if there's some consistent definition that we can use as a kind of a straw man for coming to consensus, because we need some consensus what we mean by it. Too many different variations, what the term means. So I'm going to try and attempt to throw out a straw man and then talk, as Aaron mentioned, about we got to be better at getting making decisions that allow us to optimize cost. Now, the first webinar talked about this incredible affordability crisis we all know is going on in the housing industry, and it keeps getting worse as interest rates go up to battle inflation, and inflation negates all the income gains that have been made in the workforce. So this is a real important session. I'm glad you're here. What I plan to cover today is first, I want to set the stage with the user experience imperative, and then talk about a user experience optimization framework for housing that includes performance. Then talk about why performance user experience has left the station. You all from the EBA family are in the right place at the right time. Performance has left the station, and it's really important to understand how compelling this certainty is about where the industry is going. But I also want to talk about this attempt to create a straw man for what is high performance and how do we optimize it with a series of user experience building blocks that all drive to high performance. Then I want to talk about, finally, how do we optimize performance user experience at lower cost, and always using that lens in how we think about our decisions and make our choices. So the basis for all this, as Aaron mentioned, is my new book, Housing 2.0, A Disruption Survival Guide. It's a comprehensive, unique attempt to really frame where the industry is going and provide a very strong process for all housing professionals to consistently deliver the best performance in the industry. It includes over 420 pages, hundreds of graphics, There are over 360 citations backing up almost every one of the details that we present and best practices. And what I love is some of my favorite guest expert thought leaders have contributed essays. So the book is loaded with lots of good content. I encourage you to read it. Okay, the user experience imperative, let's start with that. And we all know performance is a must-have in the EBA community. And we're all pushing towards zero energy and better health. And that's all great. And it's truly, absolutely where we have to go. But the ... but it's not enough is really important. We have to always be conscious of the reality that when people are buying homes, their expectations are so high on so many factors. And for many, zero in health may be secondary. For some, it may be front and center. But for most, you'll see lots of focus on communities with open spaces, homes that are loaded with daylight and fresh air, outdoor living, storage, smart homes, working at home, fitness at home, advanced lighting, color. I just can keep going on and on when it comes to the ever-increasing expectations home buyers have for their user experience. And you can't just be too disproportionately focused on performance in the absence of all these other experiences. I want you all to be the industry leaders. So that's why I bring Housing 2.0 to you all as a basis for giving you a foundation to become an industry leader in experience. And the reason for that is when I do my research and I go to websites I trust the most with peer reviews for home builders, the results are pretty scary. If I go to websites where the reviews come from independent reviews, not from the builders themselves, like this Consumer Affairs website. I went last April 29th. I think there were about 150 different builders listed, and it was staggering that 75% plus of the peer reviews average below 2 stars. So I believe the user experience imperative is a looming crisis for home builders because we're so well below expectations based on that kind of observation. So really, really have to focus on user experience. And when we look at the most successful companies in the world, like Apple, and you see what drives their company, this quote from Steve Jobs is all telling. If you keep your eye on the profit, you're going to skimp on the product. And if you focus on making great products with great user experiences, as my parenthetical, then the profits will follow. Every great company that's just a absolute leader in their industry, you probably will see some sort of kind of statement similar to this. We have to focus on the experience, not the profit. And so that's just a generic statement by a company who, if you put all their products on the table, it fit on one conference room table, and they have more money in the bank than the US Treasury. So that's a great kind of little anecdote, but this is the data. So this is a Watermark consulting study that showed when they looked at 11-year stock performance over a decade from 2007 to 2017, that the user experience leaders have 3 times financial performance advantage returned to investors than laggards. That's a stunning differentiation between user experience leaders and laggards. They're also 50% above the S&P 500. So the return financial outcomes are directly tied to user experience. Secondly is resilience. Another study done by McKinsey shows that the user experience leaders had a 3 times resilience advantage as well. During recessionary periods, they had shallow troughs and quicker recovery. So, you know, wherever you look, you can just see the data just makes a compelling case for why to be user experience leader. So with that in mind, Housing 2.0 attempted to boldly create a user experience optimization framework. There was none. It's been vetted for over 5 years with hundreds of housing executives to arrive at what I believe is a near consensus kind of, if not agreement, confidence in this framework. So I'm going to basically run it by you. It's based on 5 user experiences, 19 strategies, and over 150 best practices. And the first experience that's unique to the housing industry is community. Community neighborhoods where we live is massively important. So we have 3 strategies, 21 best practices, how to optimize that community experience. Then the design experience. We covered this last webinar if you want to go watch the recording. And there are 5 strategies and 50 best practices for getting a consistent industry-leading design user experience. On performance, there are 5 strategies with 42 best practices. We'll look at these today. And quality, there are 3 strategies and 20 best practices. And the last experience is sales, particularly service, which is incredibly suboptimized in the housing industry. And there are 3 strategies and 21 best practices for how to optimize sales. And this is a Housing 2.0 framework. And today, I would suggest that most builders and other housing professionals listening usually focus on 3 slices of the 5 strategies for performance optimization. And that would be building science, high efficiency, and indoor air quality. The 2 that are usually missing are resilience and water efficiency. Those would be the other 2 slices that we could add for a complete high performance. And so why has what I believe high performance user experience has left the station? It starts with just the data again. If we look at the cumulative number of HERS ratings, there are over 3 million HERS ratings done. And if we look at just 2021, the last complete year tabulated, there are over 300,000 ratings done with an average HERS index below 58, while the average IECC code home HERS index is somewhere in the 70 to 80 range. So already we see that the massive rank and file home building industry is moving way ahead of codes. That's number 1. Number 2 is just how much better the codes have gotten. The average homes are marching past codes, and we have to realize codes have gotten usually more rigorous in the last decade or so. From 2009 to 2021, about 40% more rigorous. In this chart, the vertical axis is the energy use index pegged to 1975 is 100, and time is on the horizontal axis. And so that's significant. Even more significant is that the 2015, 2018, 2021 IECC codes already represent a zero-ready enclosure. In fact, 2015 IECC is the baseline for the Zero Energy Ready Home program. So we're marching past codes in a huge number, as evidenced by the data from HERS ratings, and the codes have already gotten this much more rigorous. And there are many states who are just boldly going after zero energy codes. Of course, California is well known and has their 2019 Title 24 zero energy code in place. Oregon, New Jersey, New Mexico, New York, Puerto Rico, Washington, as I mentioned, the latest IECC codes. On top of that, if you look at policies across the country and national policies, there's so many states with 100% clean energy or renewable energy policies. There are about, I think, 18 of these states that are just marching towards all sorts of policies that will keep reinforcing high performance as a must-have feature in new homes. And then the planet itself, buildings, the share of total energy use are about 40%. Building share of total electric use is about 70%. And fossil fuel share of US electric production is about almost 2/3, about 63%. US share of total global population is 4%, while our share of emissions is 14%. So we're 3.5 times our percent of population when it comes to CO2 emissions. So the planet needs a massive infusion of commitment to reducing carbon. And we're just way over producing carbon compared to the rest of the planet. So all these bases. And then, I'm a user experience guy, so I'm going to end on this as the last business case why performance has left the station. And particularly, I want to talk about the zero user experience. I don't know if any of you on this webinar know or talked to anyone who owns particularly a Tesla electric car. And you all know they're pretty annoying. They just are in love with the company. They're in love with the design, but it's this total EV driving experience. No gas bills, the comfort, the quiet, the convenience, the incredibly low maintenance, the safety, the acceleration, the handling. the battery is low and in the center of the car, it's like driving on rails when you're in these cars. It's just stunning, and they won't shut up about just the effusive experience and excitement they're having with this new car. It's transformative. I'm going to tell you, it's going to be the same thing with zero energy homes. Instead of a great company, it'd be a great community. Hopefully, if we integrate housing 2.0 concepts and great design as well. And on top of that, no energy bills, this amazing comfort taken to a whole new level, convenience taken to a whole new level, low maintenance, safety, health, resilience. You see all the parallels. People living in a Tesla type zero energy home are going to be just as excited. And it's the other reason I just believe it's going to leave the station. And just the way you just have just this super hyper charge of growth for the electric vehicle, this will happen for zero energy homes. Okay, so what are the high performance user experience building blocks? And here's my attempt. And I welcome all sorts of ideas and suggestions, but we need to start somewhere. So I'm willing to throw a straw man out to kind of define high performance. And it begins with this understanding that's so critical on the front end. I had managers at DOE that didn't want me to tell this story because they felt I was being pejorative about high performance. It's just the opposite. But whenever you go into something, you have to understand that you have to manage risk when you're going to increase performance. So take airplanes. And what we have is the elevation or altitude we fly above the earth on the vertical axis and speed on the horizontal axis. And the first airplanes flew at low elevation, at low speed, uncomfortable. They were what they were. And of course, we're going to go to high performance air travel. It's faster, better, safer, more comfort. But it's also much higher risk. So we have obviously no oxygen at 30, 40,000 feet. So we have oxygen masks and pressurized cabins. We have incredible forces with like 150-mile-hour winds and all sorts of turbulence. So we build stronger frames that are lighter and better engineered. We're at minus 70 degrees Fahrenheit, so we have better thermal enclosures. And because we're more risk of collisions with all the planes in the air, we have better radar detection systems and avoidance systems. So you don't not go to high performance with all these benefits just because of risk. You manage the risk. And I don't know why management at DOE didn't want me to tell this story, but that's what you've got to do. And when it comes to housing, it's the exact same thing. The only difference in the vertical axis is air tightness, and the horizontal axis is thermal resistance. A low performance home is not airtight and doesn't have good thermal resistance. And of course, we're going to go to high performance homes. They have lower bills, more comfort, health, durability, and safety. You all know this. But we have to manage risks. There's greater risk, moisture, comfort, and indoor quality. And so we manage them. That's why you go to EBA conferences. That's why you learn building science. So let me lay out these risks for you and the solutions that we keep learning and getting better at with all these important venues, like, again, what we do at EBA events and training events and so forth. So high performance enclosure, first, the moisture risk. And we have to realize that when we have a low performance enclosure with less insulation, we have less air tightness, and we go high performance enclosure, there is more insulation, so there's less thermal flow, and it's more airtight, so there's less airflow. So you have a much smaller arrow at the top. And the result of that is you wind up with this colder surface on the cold side. So in cold weather climates in the winter, that would be the exterior wall, the inside of the exterior sheathing. And in hot, humid climates, that would be the interior face of the drywall would be your cold surface. So the cold side will flip depending on climate. And the problem is this, is that when you have a colder surface, you have more wetting potential. It's more likely to be at that condensation point. And at the same time, you have less drying potential because less thermal flow is now getting to the cold surface to dry it. So we have to be bulletproof, keeping moisture out of the assembly. So we do that with building science control layers. We do it with HVAC best practices that minimize getting over humid in the interior environment, and with ventilation to dilute humidity as well. So we just do the obvious solutions. We don't not do high performance enclosures because they're moisture risk. We manage them. Same thing with comfort. We have a greater comfort risk, and we have less thermal flow and less airflow. So we have low load buildings, and that entails comfort risk because you have much less airflow going through the duct systems. And we have a very, very poor track record of engineering and designing duct systems for proper airflow. We have shorter cycles because the buildings have so much reduced sensible cooling loads. The cycles are very much reduced, and when we have oversized equipment, which is the other poor track record we have in HVAC, we also have very short running times, so the coils don't get long enough to reduce humidity effectively. And lastly, we have longer swing seasons. The sensible loads are so much reduced, cooling loads are reduced on the front end and the back end, so we may have a month later before we start cooling, and we may have less sensible cooling loads a month ahead of when we normally had them in a low performance enclosure. And so if we're not cooling to meet the sensible, where's the humidification control going to come from? So we don't not build high performance buildings, we do comfort solutions, variable speed heat pumps, HVAC best practices, ensuring quality installations with airtight ducts and with proper airflow, having strategies for dehumidification, whether it be dedicated dehumidification equipment or variable speed compressors that can throttle down and function like a dehumidifier, and automated fault detection and diagnostics in the future will also come into play to assure systems installed are ready for low load homes. So we just come up with solutions. Then we have indoor air quality risks that are greater, and can, with less airflow, we have less natural dilution of contaminants. So we can have more accumulated contaminants in a very airtight structure. So what we do is we do building science. First of all, the airtight details we do keep a lot of bad stuff from outside getting in, dust, pollen, maybe smoggy air, humidity, whatever it may be. And then we get HVAC best practices to make sure, again, we're managing humidity effectively inside our buildings. And then we have a comprehensive indoor air quality strategy in place: source control, dilution, filtration. Again, the EPA Indoor Air Plus program is a great way to embed a comprehensive indoor air quality solution in new homes. So we just manage the risk. Then I also want to bring forward something else for high performance enclosures. I think we really have to be even more diligent being future ready, because there are much greater risks that will become obsolete looming ahead. And it's risks about we're having more disasters at higher magnitude. We're having more water shortages. You're all reading the news about what's going on in the western part of the country. And we're in the midst of this massive transition to all electric homes. And we have to be ready for that. And so what we do in high performance homes is we need future ready solutions. We need to embed resilience. We need to be thinking more and more parts of the country about including water conservation. And we need electric ready homes. We need high amp outlets wherever we have fossil fuel appliances and equipment, so we can switch out to electric and have the wiring and outlets ready without having all that extra cost penalty to retrofit in the future. We need solar ready homes. We need homes that are ready for electric vehicles with level 2 chargers. And we need homes ready for batteries, particularly with the ability to isolate high priority loads and have shut off connectors so that the house can operate with batteries and not have risk of letting any power go into the grid and endanger the line workers for the utilities. So we have to do all these things to be future ready. And so this leads me to my high performance home definition, if you will. These are a set of building blocks that define what is high performance. So why do we do high performance? Because we want to live better. Let's live better at home, live better in communities, and live better as a planet. That's why we do it. And what and how we achieve it that define high performance. So step one is we optimize energy efficiency. We have an efficient enclosure, efficient equipment, and efficient components to minimize the energy burden on each individual home. Step two, we manage those risks. Water protection, because we have no tolerance for getting wet in a high performance enclosure. Ensured comfort for low load homes, because we have greater comfort risks in low load homes, and a comprehensive indoor air quality system. Step three, we be future ready. We have to start adding to our definition of high performance and expectations in high performance, resilience, water efficiency in a growing part of our country, and electric ready, because the transition to electric is well underway. And the last step is get on the path to zero. Now, this is just where it's going. I talked about the user experience, and there are lots of options. You can do zero energy ready, you could do net zero energy or net zero carbon. And I'm going to wrap up today with this last part. And I think this is really important for everyone to think through their own personal strategy. How do they get on the path to zero? So there it is. That's Sam's definition of performance. I think we as a community can just work around this and collaborate and massage it and edit it. But hopefully this looks like a good straw man to you all based on this first realization that high performance increases risk. Okay, so how do we optimize performance user experience at lower cost? And now, way too big a subject to go into building science and all aspects of high performance home in a 1-hour webinar with all the other details I'm including. So this is kind of a very short list to give you a sense and taste of the kind of lens I'd like us all to use to really think through optimizing user experience relative to performance. Now, what I do in Housing 2.0 for every user experience, I do the why, what, and how. The why is the core purpose, why we even care about this experience. The what are the strategies for how we can achieve that experience, and the how are the best practices for how we get it done. So why do we care about high performance? Because protection matters. Protection against high bills with energy efficiency, protection against comfort issues, industry-leading comfort, convenience, health, water, durability, safety, and sustainability. And that's where a lot of the electric future readiness will fall into the sustainability bucket, if you will. But that's all that stuff really matters. I talk about design community and how that's what many home buyers focus on. But once you're in the home and you're over the infatuation phase of design and your community, this will be front and center. And so what do we do to get there? First, we have to control driving forces: airflow, thermal flow, moisture flow, vapor flow. And we do that with building science. Secondly, we have to optimize operation. Building needs to be completely optimized for how it operates, and that's with efficient and smart equipment, appliances, all integrated. And then third, we need health-ready homes, and we achieve that with indoor air quality best practices. And third, we want to minimize water waste. We do it by being water efficient. And then fifth, we want to be disaster ready. We do it with resilience. And last, we do zero ready, and we get there by getting on the path to zero. And I'm going to focus on the next slides I have in the time available, mostly on the very first one, controlling driving forces in building science. And I'll wrap up with zero ready. And I'll leave it for you all. Please check out our workshops and the book to get all the detail and best practices around the ones in the middle: operation, health, water, disaster. Okay, so building science best practices should be nothing new to this audience: airflow control, thermal flow control, bulk moisture control, and moisture vapor control are the best practices, first tier best practices for the strategy of optimizing building science. The second tier best practices that are more granular are for airflow. We want complete air barriers, air sealing and flashing. For thermal flow, we want to optimize insulation quantity, installation, minimize thermal bridging, and then have high performance windows. And for bulk moisture control, we want roof, water, bulk moisture control, walls and openings, bulk moisture control, foundation, bulk moisture control, and site bulk moisture control. And for moisture vapor control, we want to minimize air transport and vapor diffusion control. So this is when you go to the great sessions at EVA, you learn about all these in detail. But what I want to highlight is that the attic is by far the most egregious interface. And the reason is that you have the stack effect creating the highest pressure right up against the ceiling, and negative pressure optimized or maximized right in the basement. Now, I'm not as worried about the basement because, one, it's inherently airtight construction, mostly concrete basements and concrete slabs with minimal penetrations. And it's inherently also less thermal gradient. the ground temperature year round is like 50, 55 degrees, depending where you live, once you're below the frost line. So the driving forces are not as great that I have to manage below grade. Above grade at the attic ceiling interface, I have attics that can get up to 130, 40, 50 degrees in the summer, just as cold as it is outside in the winter. And I have this greatest exfiltration pressure right up against the ceiling. So we have to know that when we have to weigh priorities, where we put our investments and our time and attention, the attic is by far the worst. And so at the attic ceiling interface, you have two major culprits that lead to like a Swiss cheese of thermal bypass opportunities. One is all the air barriers that are up there. You have the attic hatches, and you have skylight shafts and knee walls and drop ceilings and raised ceilings and just all sorts of penetrations and so forth. And the air leakage, again, you have recessed lights and plumbing, electric, and you have the attic hatch, and you have all sorts of leakage opportunities right where you have the greatest and most egregious interface in temperature, right, and pressure. So this is the most significant interface, and this is a solution we've come up with. This is, as you know, when you do air barrier checking for any design, it's called a red line test, where without lifting a pencil, you draw a red line on the exterior air barrier and the interior air barrier. And this is a typical construction, probably done in over 90% of new home construction, which is a vented attic. And the trouble is you're missing a top side air barrier at the most egregious interface. And the reason for that is we just have the fluffy stuff and no top side air barrier. And if we're doing a good job, we have wind baffles and raised hill trusses, but still it's nearly 50% of the most egregious interface is missing an air barrier. And you have a lot of pressures and driving forces. You have more humidity in the attic and hot and humid climates. I mentioned the temperature gradient. When winds blow in through the venting, you have another wind pressure gradient. So you have lots of forces working against it. I'll also mention that my cellulose insulation I blew in at 24 inches, dropped over 6 or 7 years down to almost less than half, 12 inches. It just compressed. I think part of that, I'm guessing, is also, I think, is it absorbs some of the moisture, it gets more dense and settles. But this is not optimizing home performance. So we even compound it when we throw the HVAC up in the attic. It couldn't be a worse location. The southwestern states, this is still a common thing to do. And so this is just a horrible situation. So we have to realize that unvented attics are a friend because they're faster, better, cheaper. And the details of how you get to that, again, way too much time. I'll cover some of them a little bit later. But essentially, we faster because I can drop SIP panels in a day and save maybe 2 or 3 days of putting in trusses and insulation and everything else that goes into a typical attic. And I have reduced rework because this is so much higher quality offsite constructed system dropped in place. And it's better because I have all this additional conditioned space. It's more efficient. Instead of having a 130-degree attic here in the summer and a 70-degree space here, I have maybe 85-degree and a 70-degree space. I reduce the temperature gradient for more comfort, more efficient, and it's also more resilient. Without the venting, I don't have as much opportunity for embers to be drawn into the attic and ignite the framing. And when wind that is blowing at 100 miles, 120 miles an hour can't get through the venting, I don't create a pressurized attic that can blow the roof off. So it's more resilient, more comfort, more efficient, more conditioned space, better. And it's cheaper because I save all the costs for venting, ridge, soffit, gable, air barriers and ear sealing go away that I showed you before, and the cycle time reduces costs significantly. So there's a unvented attic compared to a vented attic. And it's a better home. And the question is, does it cost less? We'll talk about that a little bit later. And in new construction, in existing home construction, I watch so much time being wasted on all these complicated programs. We should just keep it simple. One national comprehensive attic upgrade program across all 50 states. This works everywhere, and it's a no-brainer. Where wall improvements are an incredible challenge. We don't have all the control layers in the wall assemblies, and it makes it real dicey how we figure out what we can do without doing more harm than good. But the attic is always easy, high return, and it can be systematized so we can do the nation at a fraction of the cost instead of we do just hit and miss applications where we do it. We should have one national program, what I call Attic Plus. In the attic, we put in the air barriers, the baffles, the air sealing, and insulation up to at least IECC 2012 or 15. Plus, if the ducts are up there, seal the ducts, possibly put some shade screens on south and west facing windows in hot climates. This is so easy to do and set up a national program. I mean, high performance with energy storage is just so much friction, so much cost, all the front end testing and diagnostics, and then come in and the front end, back end testing and diagnostics. By far, it's a better approach, but we can't afford it. If every home, and we did this en masse, a Attic Plus system, that is high performance, that's better at lower cost, and just systematize it. It's the most egregious interface. Now, when it comes to airflow, the air sealing targets, you know, these are all over the map. It depends on what programs you're doing, what codes you're doing. I'm going to tell you, everyone should be doing basically 1.5 ACH50 or better. Just get used to it. And that way you're ready for almost any program. If you want to do passive 0.6, fine. I think you're great at 1 or 1.5, but you can kind of pick your poison. But everyone in the country should be at 1.5. And it's not hard to get there. And if you start using the offsite systems, I'll again talk about a little bit later, they're going to inherently let you get to that target so easily. So everyone should be focused on getting the 1.5 ACH50. And also, you got to realize that the bang for the buck, when you got to control moisture issues in assemblies, is by far air leakage versus diffusion. On the left, we have a hot, humid climate, and you see that over the entire cooling season, there's 10 times more water through a 1-inch hole in a 4x8 sheet of drywall than just diffusion through that same 4x8 sheet of drywall. This is just Steve Rick's study, and it's not even painted drywall. With painted, it'd probably be closer to 20x difference in terms of how much goes through a 1-inch hole instead of diffusion. And in cold climates, where I'm most concerned about vapor going from the warm side into the construction assembly, it's 100 times more vapor flow through a 1-inch hole in a 4x8 sheet of drywall over an entire heating season than just a 4x8 sheet without the 1-inch hole. Air leakage, air leakage, air leakage. If you want to control vapor flow, that's where you have to focus your attention and get the most for the least cost. And also, if you want to start really having bulletproof, like no risk solutions, we have to start looking at some of these advanced technologies. I'm a big fan of air barrier, and the picture writes manual air sealing. And you compare that to the digital air sealing with these automatic systems like air barrier that just injects the aerosol throughout the house. Any hole, it will move through the hole, accelerate, and drop the air sealing material and seal it completely. And it will be digitally measured on the computer screen, so you know precisely when you hit your air leakage target. And it'll be at a level you can get the passive house, whatever target you want, faster, better. And if you count all the costs, I think, of this manual process of trying to seal homes, better and cheaper. And so again, I'm a big fan of faster, better, cheaper. Reduced time, faster compliance, better because of digital precision. You have a guaranteed target and enhanced durability. The long-term performance of the air sealing is incredible. And it's cheaper when you look at the true costs, including cycle time, labor, materials, and rework. You'll see that you can do the digital air sealing cheaper. So we just have to be smarter about how we go after the biggest challenge in high performance construction and building science: air leakage, air leakage, air leakage. So do consider these advanced technologies. And then when it comes to the thermal control layer and what's the quantity of insulation, you know, there's not a lot of debate. The latest codes are there. I mentioned they're all zero energy ready or better, 2015, 2018, and 21. So I've mapped them out on this one chart. And I really want to highlight some of the real excitement about why to go to 2021. In climate zone 3, you got to do slab edge insulation. Zero slab edge insulation won't work. So R10 for 2 feet absolutely is a must. And climate zones 4 and 5, R10 for 2 feet, I don't think it's enough. I really like the 4-foot increase with 2021. So just go 2021 is my recommendation. When it comes to 4, all the codes are the same. 13 and 1 and 2, 19 and 3 and 4, 30 and 5 and 6, and 38 and 7 and 8. Basement crawl space insulation, the only thing change is that in marine climates 4 and climate zone 5, for basement insulation, you could do 15 in framing, or hang a 19, 15, you can hang a 15 bat or do 19 in the framing, or you can do rigid 5 plus 13 for 2021. So the only difference in 2021 is they give you an extra option of 5, rigid 5 plus 13. And that's probably what everyone should be doing to get a continuous thermal bridging control. And then for ceiling insulation, the attic insulation jumps from 38 to 49 and from 49 to 60 for the colder climates. And again, that seems like maybe that's too rigorous, but realize if you're doing a raised tilt truss, the 60 drops to 49. And if you're doing the unvented attic, then the 49 drops to, I think, about 38. So 38 is just not too much insulation. We'll see even this works. And these are the prescriptive numbers, which you can negotiate down with the overall U sub O calculation as well. And the only thing that changes in the wall framing is that they add rigid insulation as a for cold climates 4 and 5. Instead of doing 20 without rigid, 20 plus 5, and or 13 plus 10. And again, it's just a really good recommendation to just manage the moisture issues for condensation inside the assembly. So my message here is everyone should be moving to IECC 2021. It's the summary of all this discussion. The other thing is to also consider with thermal control is greater accountability just because of infrared imaging. The cameras today that cost $400 or $500 used to cost 20 or 30,000, and they do a great job revealing any defects. You just don't want to be seen with it. I'll say that the band joist is one of the bigger challenges for managing thermal control, and it's because it's really doesn't work to do the old solution, which is pack and fibrous insulation. It avoids misalignment without an air barrier on the inside, stopping vapor flow to the cold surface. You have compression, you have gaps. All these things are just common when you try to squeeze fibrous insulation into all these tight spaces, and it just, job after job, it's just not something that the field labor infrastructure can really deliver consistently. So really, you have to either go to either spray foam, and spray foam has challenges because you're basically bringing a manufacturing process to the field, and you have all these challenges both with the skill it takes for the applicator and with the absolute rigorous conditions environmentally for when it can be installed. And I've seen lots of jobs where you see gaps where it pulls away from the framing because of various issues, either with the mixture or the temperature when it's applied. So I will recommend people start considering SIP band joists as a way to start to get to know SIPs. If I do a SIP band joist, it's faster, better, cheaper. I reduce the cycle time because, one, I don't have to install headers above windows. I have a kind of a bond beam wrapping around the entire perimeter. And I reduce rework because it's just easier to do consistently than going back and checking the fibrous insulation or spray foam. The savings are better, it's stronger, and it's also more inherent quality control. And it's cheaper by saving headers and not having a separate spray foam contractor who's different from maybe the fibrous insulation used otherwise in the wall framing in the attic. So anyway, again, SIP band joist is a killer application. Also, I mentioned how important thermal bridging is at slab edges, and why I'm so glad to see the 2021 code kind of finally close that gap. It's like a superhighway, and you can see the infrared image of heat coming in cold weather and heat going out in hot weather, and heat coming in hot weather and heat going out in cold weather. And essentially, There's lots of solutions from basic rigid insulation that can be covered with a fiber cementitious siding board or metal. There are even insulation products made that are both the form and the insulation, and it's less timing, less work, less labor. It's just leave the material in place and pour the foundation with all the insulation around it. So more and more the solutions for good slabage insulation. Our value killers by far thermal bridging is egregious. It just undermines so much other good work. And these are all the options we have with the various thermal bridging performance. Conventional framing has about a 25 to 30% framing factor. So it means 25 to 30% of the wall contiguous wood. And wood has 3-4 times more heat flow than insulation. So it's a real thermal flow killer, if you will. Advanced framing can knock it down to about 19% framing factor. So you're going from 2x4 16-inch on center to 2x6 24-inch on center, plus some various details for 2-stud corners and lattice at wall intersections and details you know about. Some people like using staggered stud framing. So you have 2x4s alternating. These are 2 feet apart and these are 2 feet apart. And this way you have no contiguous wood from interior to exterior. But even still, that's 12% framing factor. I have some friends that like to use double wall framing. That's still a 10% framing factor when you count for top plates and all the trimmer on windows and doors. And then structural insulated panels are about 5% framing factor. They use these splines and other details that are kind of nifty at minimizing thermal bridging. And of course, rigid insulated sheathing gets it down to about 2% framing factor. This is where you should live. These are the only 2 options I would consider. By the way, when I say structural insulated panels, it could be any number of offsite options. Insulated concrete panels work, insulated concrete forms, precast concrete with the insulation embedded would work. So, you know, structural insulated panels is the most common, so that's what I show here. But you have to be, and I believe today, at thermal bridging where the framing factor cannot be higher than 5%, and you're still a high performance home. So it's just way too much a hit on the overall performance. And, you know, when I compare those 2 solutions, you know, the rigid insulation versus SIPs, and I just look at it this way, it's just stunning how much complexity you take out of your life and how much risk you take out of your life when you go to SIPs from all the moving parts you have. You know, you have the siding, you have the air gap, which you still have with SIPs, but then you have the rigid insulation, you have the weather resistant barrier, you have the other type of insulation in the cavity, and you have all these moving parts you have to control. Some of the rigid insulation was more prone to shrinking and creating air gaps. I think it's starting to figure that out a little better now, but you know, faster because your enclosure goes in right away. The drywall can be installed on the exterior walls without having to align with the studs. You don't need the studs anywhere. It's less cutting, less waste. It goes in faster. It's so dimensionally accurate. The trim goes in faster with less waste. And that's better because it's just inherently kind of bulletproof airflow control, inherent quality control, dimensional accuracy, 50% less wood for those that are resource and carbon footprint minded, and less waste in general, and cheaper when you look at lower true costs and count all the benefits and quantify them more out. And let me give you an example. Here's a framed house with a basement and a framed insulated wall for a conditioned basement, and then the truss attic, and you have the living space. And what I could do is trade off the basement for the upper level of, by using that space where the trusses are, with a unvented attic using, let's say, SIPs. And I instead can build a shallow frost protected footing. And then I have above grade space instead of below grade space, and submit that the above grade space may be worth 2 or 3 times more than the below grade space because of daylight, and just, it feels better not to be below ground. And so the benefit, so there's your above grade volume that you've traded off for the basement, and you want to say up to 6,000 going to the shallow frost protected footing. The framing that's built, that you have to build for the insulation, I don't have to build on the 2 gable ends, so that might be another $1,000 to $2,000. The egress windows I need in basements, I don't need those. all the air sealing and air barriers at the attic ceiling interface go away, the attic venting goes away. Possibly you can use a crane that puts the SIP panels in place and then also lift up the roofing materials and underlayment on the roof as well. Reduce waste, reduce time. These are all significant cost savings. And then if this is worth 2 to 3 times below grade space to have above grade space with daylight and views and so forth. And so it goes from retail of $150 a square foot to $300 a square foot. Quickly I'm getting $40, $60, $70, $80,000 of extra value for this above grade space. And that's when you count all the cost savings and value, you see this is faster, better, and cheaper. And we don't. Normally, I see most builders compare a SIP fitting package to a framing package, and there's no way you get the right answer doing that. Now, the other thing to consider is I've had some builders tell me that my customer expects a basement in this cold climate. I have to provide a basement. So provide the upper level, and you have all that additional useful space. Now you can shrink the footprint and have a net same, or just add spaces for work at home, fitness at home, student work at home, whatever it may be, or all the new needs we have post-COVID. So we have all the same cost savings I mentioned earlier, and we have all that extra space that might be worth $200 or $300 a square foot. And quickly now I have $100,000 to $160,000 additional value by grabbing that volume. When I talk about offsite construction, I always refer to the Swedes as my heroes. They would never build a home and not use all the volume created by the roof slopes and framing. So just for your consideration about lower cost for high performance. Moving on to windows. Windows are like the weak link once you do the walls really well. Airflow, thermal flow, moisture flow, and vapor flow. So I've done all that good stuff, and then these windows are like funnels for heat to flow out in the winter and flow in the summer. And so I want to just highlight just how much you compromise. So in a cold climate, I ran some calculations on one website. They have a calculator for what's the net R value for the wall assembly. So I assume 50% window to wall area, which is much lower than average, about 20% of window to wall or higher. And this is the R value of the wall assembly. R0 would be no insulation, or 18 walls, or 39 walls, or R60. And these are the various window options. Energy Star 0.3 would be R3, R5 would be R7, R10 windows. These are the U-value equivalents. And so if I have a 6-inch frame wall and I have an Energy Star window, the net wall R value is reduced over 30%, over 33%, or 11. That's significant. But if I have it, that's a 6-inch wall. If I have a 13-inch wall, R39, it's reduced like 60% to R15 with an Energy Star window. So I'm paying all that for the thicker walls, all the framing and insulation to get the R39 wall, let's say. And if you don't have a high performance window, you've negated most of the benefits, not that much benefit. Or I could take the R6-inch wall, R18 assembly, just put in a better window, R7 window, and get the same performance as a 13-inch wall with the Energy Star window. That's how powerful windows are. Now, look at the R60 wall. It reduces like 70+% with an Energy Star window. It's slightly better than the R39 wall and only 30% better than the R18 wall. So it's huge how much impact windows have in cold climates. And by the way, I can get almost the same with the R60 wall, which is like, it's like an 20-inch wall with a 6-inch wall with an R10 window. So really focus as you get colder and colder climates on the R3 window. And the great thing is you can get them at lower cost. The thin triple low E, I think there are 2 or 3 manufacturers who are just starting production now, limited availability, but within 3 to 5 years, this should be out there quite a bit. The secret sauce is that this interior pane is not a normal window pane like you have in the double pane window or triple pane window. They use the glass like you would use in an LED TV. It's a very thin glass, and they get some extra surface coatings. It's faster because it's lightweight with the thin interior glass. And so you can install it with a crew of 2 people, and sometimes the extra weight requires a third person to lift the window in place. It's better because it uses krypton versus argon fill, and it has 3 layers of glass that go either R7 or R10. And it's cheaper because it's much lower cost than conventional triple glass that is all the same size. And manufacturing plants don't have to retool. This dimension is across the window is the same as a double window, so you don't have to retool the plant to make a triple window that's thicker. So lots of cost benefits. We'll see how the manufacturers price these windows and see if they pass those cost savings on to the market. Also, I want to say that you can't choose all these performance options in a vacuum. There's a nexus between what you choose for high performance and how you optimize resilience. So for instance, I live in a location with any kind of wildfire risk. My friendly unvented attic like SIPs or spray foam is a great complement. Unvented crawl spaces is a great complement, and non-combustible materials. In conflict would be vented attics, vented crawl spaces, and flammable insulation. In high wind, high impact risk locations with hurricanes, tornadoes, and so forth, unvented attics again complement because you don't have the winds able to kind of flow through the vents and pressurize the attics and impose stresses that can blow them apart. And then concrete and SIP off-site construction would be very complementary, and operable shutters that can actually be used for hurricane events would be great versus big shutters. And in conflict would be vented attics, wood frame walls that aren't reinforced, and large overhangs that function like a sail and create more stress. In earthquakes, wood frame might be better, and masonry walls might be in conflict. In flood locations, raised homes and concrete masonry walls are your complement. Unvented crawl spaces are in conflict, and insulated slabs. And severe winter weather, vented attics might be more difficult because vented attics might be better because you don't create you create a cold surface at the attic sheathing, so you don't have less risk of ice damming. Now you can do vented attics with an air gap and then another layer of sheathing in the roofing to also create a cold surface, but you have to manage the risk. Okay, I'll also talk about it when we make these choices and we pick what to do for high performance, that more and more, as I talked about in the first webinar, the industry has to move to offsite. All the factors I discussed then are driving us. The trade availability, the trade costs, the supply chain issues, the time savings, all the benefits of offsite. I have the benefits here: reduced cycle time, reduced trades, higher quality, more strength, cheaper true costs, reduced rework, substantially less waste. All these benefits are waiting to be grabbed. We have lots of options, kits, panels, could be frame panels or SIPs, insulated concrete panels, precast panels, modular hybrids. We use panels in the less intensive spaces and more intensive spaces with lots of trade work. Kitchens and bathrooms use cores, 3D printing. We covered all these in the first webinar. I encourage you to maybe go take a look. But the big thing I want to talk about is cycle time. With site-built construction, design engineering, permit approvals are the same as offsite. But once you have construction starting, you have to wait for site development before you can do construction work, where the site development and the building construction happen concurrently with offsite construction. And then during construction, all I'm doing is assembling panels and modules, which is much faster and infinitely less waste than with normal building construction and hardly any site restoration. So I can have all this time savings, could be 30 days, 40 days, that adds up to like $30,000, $40,000, $50,000 of value. And when you look at other countries, we're way behind using offsite construction. Sweden has been at 85% for a long time. Japan has moved up from 17 to 20% in 2013 to 2018. Germany, 15 to 20%. UK, 7 to 11%. We've been sitting about 2%, 3%. So I predict for all the pain relief opportunities to go to offsite, there's going to be a big move, but offsite has to be high performance. It has to be optimized designs. All the things I talk about Housing 2.0 have to be integrated with offsite. Too much in the past, offsite construction meant often lesser quality design and lesser quality product. So I think offsite's a whole new game now, and do look out for that and how to integrate with your high performance goals. So more and more and more zero energy offsite options out in the market. And this is the true cost bidding tool I developed for SIPs, where I can offer all the benefits of time and quality and savings from waste and so forth. And when I simply compare for one builder, his framing package to the SIP package, the SIPs cost $2,200 more than the framing package. But when I add all the other cost savings and added value, the SIPs actually saved $18,000 and added $17,500 in value for almost $36,000 net benefit. So the problem we've been having in high performance is we're not counting all the credits and debits, all the value, all the cost savings, really thinking through this. I encourage you to, at the EBA conference, Jack Armstrong and I are going to be presenting this whole SIP true cost bidding concept and how it works, and I encourage you to attend that. And just to wrap up, I'm going to talk a little bit about comfort. This is really an epidemic of poor quality installation when it comes to HVAC. These are the numbers from a detailed study by NREL, National Renewable Energy Laboratory, to DOE. They looked at hundreds of homes and found 70 to 100% of field measured HVAC systems evidenced at least one performance compromising fault. I highlight a few numbers: 30 to 90% oversizing. Refrigerant charge was low 30 to 80% of the time. Duct leakage occurred 2/3 to 100% of the homes being tested in various markets. And airflow was an issue in 50 to 93% of the homes. That's staggering. It's an epidemic of low quality HVAC installation. And so I think, and I predict that automated fault detection and diagnostics has a huge opportunity. Manufacturers have to figure out how to introduce it and not completely just create havoc with their installation companies that work with them and put them in a bad position. But already there's companies like Emerson that has a product called Sense and Predict that can be in 15 minutes installed on any system. 10 sensors and a few kind of connections, and you're done. And you have in real-time app, you have the airflow, the refrigerant charge, the flow across the coil. All those things are showing up right away. And they're going back to a central center that's monitoring in real time, and they contact you when you have a fault. And so this will be a real issue as more and more homes get these monitoring systems. And a lot of the defects that are embedded in our installations are revealed. The other thing about HVAC is, we have high performance enclosures. It's crazy to do the old type duct systems that went out to the extremities. You can do it faster and better and cheaper with a compact duct system. Less cycle time, better comfort, lower bills, easier to install and condition space, and it's cheaper labor, materials, and callback. So more and more we have to go to compact layouts. Also, there's some exciting new innovations like plug and play ducts that just snap together airtight. How these systems work is you have a big plenum on top of the air handler that has all these 2.5-inch holes, and then you run as many ducts to a room as you need, knowing that each of these 2.5-inch ducts carries about 25 CFM. So I have 70 CFM for a great room. Let's say I run 3 of these to a great room and have 3 grills. This is what a house, so this is basically how it works. I'm excited about this innovation. And I'm also excited about the advanced comfort systems that are out there in the market today. The advanced inverter-driven heat pumps. This is Mitsubishi's. It has smart. It knows if people are in space. It knows how to optimize mixing. It has duct systems that are very compact and can be in the ceiling and get to a number of different rooms. And because it has so much ability with the variable speed inverter-driven heat pump to throttle up and down, they're looking forward to coming up with some really incredible dehumidification capabilities. So more and more you have to look for some of these advanced technology solutions to manage all the extra risk with the HVAC installation infrastructure that on record has not been doing a great job. I mentioned I want to just wrap up with getting on the path to zero, and then I'll give you some final recommendations. So here's the basic roadmap for zero. If I look at just operational energy, we start with a code minimum home, go to a high performance home, zero energy ready, zero net energy, zero energy all electric, and zero carbon. I'll explain what these are in a minute. And the way in the future, we're also going to care about embodied energy, and anywhere along any of these steps, you can start minimizing embodied energy. With embodied energy, the real culprits are the concrete, the steel, and some of the more egregious foams. And I think we can get to simpler solutions than all these very complex metrics for carbon, but the market will figure out what to do. But essentially what I want to show you is what happens for 4 key parameters. Performance, which I showed you, is it's comfort, it's health, it's building science, it's more and more going to be water and resilience as one parameter, energy consumption as a surrogate for efficiency. And we can have consumption with fossil fuel, which is light blue-green, and dark blue-green is with no fossil fuel, all electric homes, if you will. And then we can have renewable energy, which is green, and embodied energy, which is orange. And if you look at a code minimum home, you have a certain amount of performance, which is just, let's call this the baseline in a code home. And this is, this is the improved energy consumption we've gotten to with all the codes. No renewables required except in California. And then we have embodied energies the same for almost all homes, unless you start addressing that in the design process. So the high performance home, we start with the code home and we add more performance. It could be air quality improvements, or it could be have to do durability improvements. And we reduce the energy consumption. And that's what we do with high performance. It could be Energy Star, for instance. It could be Indoor Air Plus, just improving the performance of the air quality. That's what high performance programs do. What zero energy programs is built on that. They further improve performance, so the more and more performance, further reduce the energy, and that's your zero energy ready home. It's ready to go to zero. A zero net energy home takes that zero energy ready home and adds a renewable system. Now, since there are possibly fossil fuel system components in the house, the utilities only let you produce as much at a maximum as much energy as you buy, plus maybe a few percent. So if you have fossil fuel, you can't replace all of that in a zero net energy house. The only way you could would be if you had an electric vehicle, but that's another story. Now, zero energy all electric home, what happens is we're going to change the fossil fuel equipment out and have everything all electric. So all the energy consumption is electric. Now we can raise the renewable contribution to match all that electric consumption. And finally, in zero carbon, we take that and we further add to the renewable side and reduce the carbon footprint as much as we can by eliminating concrete, steel, egregious foams, as I mentioned, and you get into zero carbon. So that's the path. And wherever you are, I don't care if it's Energy Star, zero energy ready home, all the variations that are coming for these other options, just get on the path to zero. Everyone should be figuring out what works for them, see where the future is going, and keep finding opportunities for when they can take the next step and the next step. But any of the steps is great. I don't care if you're Energy Star or anything above. It's great that you start getting on the path to zero. And so here you for high performance, Energy Star, Air Plus, Water Sense, Fortified Home for Resilience, and the green programs. For zero energy ready, you have zero energy ready, FIAS and Passive House qualify and require these as a prerequisite to do zero ready. For zero net energy, you can do zero energy ready home, FIAS, and zero energy certification. I think the Living Building Challenge group, this will be a future one for zero ready. And for zero electric, there are programs being developed by Energy Star and the Zero Energy Ready Home Group at DOE. We'll see what they come up with. SMUD already has an all-electric smart home certification, and zero carbon is a zero carbon certification by the Living Building Challenge group, and then the Carbon Trust has their footprint measurement. So lots going on. Pick your path. You have lots of programs to start working with and get on the path to zero. And the key thing I want to talk about is zero is a must-have because of all the benefits, cost savings, and added value. Due to time constraints, what I want to just say is essentially utility cost savings over 30 years are worth about 20 to 60,000. And note, I reduced the HERS rating reported savings by 50 to 60%. I'd ask you all if I had time to write in why, but the answer is because the HERS rating is pegged to a 2006 IECC, which is a non-realistic baseline for a new code home. And so you have to knock off about almost half of the energy savings reported by the HERS report. But so it's roughly 20 to 60,000 over 30 years, the value of the energy savings. The maintenance savings, I have assumptions and details in the book that show how I come up to $1,000 to $30,000. Smaller HVAC systems and smaller duct systems, or say 2,000 to 3,000. Future ready, the added values were 15,000 to 30,000. Just the disruption you avoid and the cost penalty having to add to your house once it's finished is worth so much money to your clients. The health cost savings are $30,000 to $40,000. Again, I calculated this in the book. You'll see it's based on the out-of-pocket expenses for the average household. And I assumed, I think 30% or 25% savings opportunity if you did a comprehensive indoor air quality package. The value of less sick days is 10,000 to 15,000. The value of water conservation, the bill savings are worth 8,000 to 12,000 over 30 years. Hot water and demand is worth, I believe, 1,500 to 3,000. You're saving about 5,000 to 8,000 gallons going down the drain, and you're improving the efficiency of the hot water heating system. And with resilience, insurance cost savings and supply disruption, power value are very significant when you include those in your package. All this without, this adds up to a much bigger number. I discount this, assume that all these happen at once, and I come up with roughly $100,000 to $150,000 of savings and or added value. And if I go and look at the total user experience, performance is only one part. There's your 150,000. On a typical home, I believe that's worth 30 to 40% of the cost of the home. And if I add all the other cost savings and added value from community design, quality, and sales that we document and tabulate in Housing 2.0, and then I discount it significantly, assuming that all these happen simultaneously, it's worth $130,000 to $280,000, or the benefit in terms of the total cost of the home is 30 to 70% cost savings. So how do we ignore all that benefit? This is the secret sauce for high performance at low cost. Don't just do performance in isolation. Do it as part of housing as a system of 5 key user experiences: community design, performance, quality, and sales. And lastly, here are the final recommendations for architects and builders transition to a US user experience business model today. And what I do with builders is I first help them develop a customized framework for their business based on their tolerance for change, their market conditions, their preferences, their climate factors, the demographics. And we need to come up with a framework for every builder that becomes their brand in effect. But I lay out all the possibilities I've been able to work and identify with hundreds of builders over 5 years. Now I need you to figure out what's right for your business. Explore mass customization opportunities to start getting repeatable building blocks for huge cost savings. Start with kitchens and bathrooms. Stop always coming up with new kitchens and bathrooms. Start getting building blocks you can do for lower cost and are fully worked out and engineered to be optimized. Track the availability of emerging software as service aggregators to digitize now your BIM-worthy designs that are optimized and have mass customization, and evaluate offsite options. Do the math. That true cost comparison I talked about earlier is critical, and that doesn't even account for all the cost savings that come just from lessons learned. For many builders, when I learn a new system, they can save 20, 30% or more once they nail it down and figure out how to use that new offsite system or whatever it may be. For high performance home programs, first of all, for your certification programs, train your partners to be industry leaders. Don't just train them to be Energy Star or to do building science. Train them to do all the 5 key user experiences. If they also deliver high performance and great designs and communities, then they're going to be positioned to be the most successful. and follow suit when you do recognition and award programs. We did this with the Zero Energy Ready Home programs. We prioritize great designs and communities as a basis for who would win the awards. So it's a very significant factor on who was decided as a Housing Innovation Award recipients in that program. I think all high performance home programs should be recognizing homes that are best ambassador for high performance, homes that also reflect great communities and great designs. Research programs need to be integrating better with mass customization and offsite constructions. And particularly, I think we have to realize research isn't maybe the primary solution. There's so much great work going on by so many new companies coming in. I would just prioritize aggregated demand programs. Just create targets for user experience and cost and performance, and just put out prizes for industry to meet those great challenges. And lastly, affordable housing is by far the most important target to also do user experience. We build too many low-income housing projects where the experiences are left out and they have hardly any chance of appreciating, creating sustainable value and investment opportunity for the demographic that needs it the most, low-income households. So set up user experience optimization training programs with special curriculum for affordable housing. A lot of the benefits of user experience optimization all drive towards reducing complexity and optimizing simplicity. All of them are dramatically aligned with the cost reduction goals of affordable housing. Shift the focus from first cost to all the 5 user experiences. It's a critical path for low-income households to have any chance of asset growth. Invest in the future of housing. Work with software service companies on digitized designs with mass customization that you repeat over and over again. They optimize the ducts layout, the plumbing layouts, technology layouts. They optimize all geometry. They optimize all the lighting. Everything is optimized for cost performance at the lowest cost. It's just where you need to be. And leverage offsite with aggregated demand. Many different housing programs can leverage through their needs for quantity of housing. Some amazing, I think, opportunities to partner with offsite construction. But you got to set rigorous cost and user experience optimization targets along with high performance targets. So that's a lot. And so if you want to benefit from the whole learning system the Housing 2.0 program brings to the table, the context, the skill, concepts and skills are all covered by the book and workshops. You can practice, learn by doing in action groups that focus on how we optimize designs. And we have continuous improvement through thought leader series of amazing experts coming to the table and building more and more on all these skills and concepts. So I welcome you to the program. This is where you can reach the program. This is where you can reach me. And I hope this makes sense. We just have to do better. This is just the business climate we're in. And hopefully this is a kind of a guide path for you to kind of get on the track to do that. Thank you so much for attending. This has been so much fun to do this series.
That's fantastic. Sam, one comment, there's another pot of money there. It's the 45L tax credit, isn't it?
That's for 50% cost energy savings.
Yeah.
I think they fixed the software issue, but I'm not sure. The software had a lot of loopholes in how you can qualify and not be as high performance as you would like. I know our team at DOE was working on that. I don't know if we got it through Treasury yet, the changes, but it's a step in the right direction. I'm always frustrated they don't use the programs as a target. We invest in all these federal programs, Air Plus, Energy Star, Zero Energy Ready. Just attach an incentive to achieving those targets or getting a home energy score in an existing home that's 7 or better. And so if you buy an existing home and you put up an escrow and investment to take it to a 7, you get this big tax credit.
Yeah.
That way at transaction, we have an opportunity to improve all the existing homes. And on the new home side, we created this program, but then we created a loophole because of the software. Just reference the federal programs. You already made the investment as a federal government. Then you come up with a federal program and ignore the federal programs. It just drives me insane.
But what I'm saying is builders should be looking at the 45L tax credit. It's out there for you. If you're following what Sam has laid out here, you're going to qualify at some stage, usually. And it's significant. If you're doing multifamily housing, $2,000 per unit for building it right. The other thing I want to talk about, we had a lot of questions come up on this, Sam, is the resilience part of it, right? I mean, you showed the slide where we have states that are going to renewable energy, and that's a great thing. But what we forget about, and we're kind of reading here in the upper Midwest about rolling blackouts, is that there's a resiliency factor. There's a reason you want to have solar or battery or bi-directional car charger in your house. It's for the resiliency of the occupants, right?
Yeah, although you look at how California does it, and it's really crazy because the way it's set up in California, you have to put a solar system, but it's not going to work if there's a supply shutdown because the systems aren't set up for that. So it doesn't get, it's the worst of all worlds. If I invest in solar that's distributed generation or utility scale, you get like 2 or 3 times more power than you do with rooftop systems. And if you do rooftop systems and you look at the income, you see it's income regressive in terms of who's benefiting from who's buying homes in California. So we're investing in the wrong application. We have to invest in renewables, but if you put up utility scale systems, everyone gets them, low income, middle income, high income. That's not the case with the current code. And why do you have to go into the micro power plant business to buy a house? Why is that a requirement? So I have lots of problems. I'd rather see all that investment going to making the homes that are at risk of fire damage being non-combustible, roofs and walls, again, unvented attics, not putting HVAC systems in vented attics. There's so many other things to do that are so much more benefit. So it's really staggering to me how it's done. But if you're doing it with batteries and solar and you have the right switching requirements that meet the utility demands, that adds like 15, 18,000 of value if you look at what people pay for a gas generator, plus you avoid the monthly running it for a few hours and annual tune-up that costs a few $100s that you'd have with a gas generator. So a battery system with a solar that would be set up to function during a power failure would be a great resilient strategy.
Right.
That's not what we're getting with the current code.
I think a lot of feedback, Sam, a lot of folks were commenting throughout that this tie-in between resiliency and insurance rates, I think we need to explore further because I know some of our builders with EBA down in Florida are telling me that habitation insurance in Florida has doubled over the past couple of years. So if you're not thinking about, or if you can prove to the insurer that you're a much more resilient structure, it becomes a license to operate issue. You can't afford the insurance, right?
Well, if you're certified to fortified home, you'll get a 20 to 60% discount on insurance. If the average home insurance now is about $1,500, the 20 to 60% savings is $300 to $900 a year. How much energy are we saving with an Energy Star home? Maybe $300 to $400 a year or less. So the insurance savings is as much as the energy savings, in that case.
Right. Sam, one comment that came up is, what are your thoughts on ICF, ICP construction? I think I know the answer, but it provides energy efficiency, storm resilience, and superior fire ratings all in one system. What are your thoughts around that? ICF, ICP?
Very much so. I think it's, I don't think it has the infrastructure that, again, SIPs would have, and also it has still challenges with 2-story construction, because I think I don't know that I've seen really good details how to get that ledger block into the wall assembly so you can build the floor framing and then the second story. But for at least for one-story homes, it's an amazing wall assembly for impact, for fire, for pests. Termites are probably as much of a disaster risk for many people
Right. It's a
as
slow-moving
anything
disaster.
else. And so sure, termites can eat through foam, but they don't have any goal to do that. It's just concrete. And
Great.
so insulated concrete panels have some very interesting possibilities. I just don't see the infrastructure to get it out there as much as SIPs. And but all the offsite options really excite me. I've seen some amazing modular. I saw that Centex Communities, the number 10 builder is going to do a huge project, all with 3D printed homes. 3D printed homes for hundreds of homes. And so, that's when a builder that's number 10 in the country is moving to something like 3D, that captures my attention.
Yeah. I just want to put another plug. I caught an email while you were talking that you have an action group that's forming right now. I think you've got spots for 4 more builders in that.
I think three or four. I have to tell you, Aaron, everyone who's been in the action group, where we customize the design framework for them, and then we bring in some actual design and then apply their framework. Everyone that's come has saved like 10, 15, 20, 30, 40, $50,000 cost savings and added value. That the process works. If you really just put on this lens and you extract all this waste and complexity and you add everything that is a sure thing in terms of a user experience, the outcomes are truly amazing. So thank you for mentioning that. We do have, I think, 3 or 4 slots before we close it out. And I don't have the start date, but it starts in about a few weeks or a month.
Fantastic. I got to join one of the action groups. I brought a plan, and just like you said, it was just incredible feedback. I think worth thousands of dollars of your time, Sam. But then I had 5 other builders that were high performance builders that also gave great feedback. Have you thought about this? What about this? So I'd really encourage you to sign up. Reach out to Sam at truehomefacts.com. Sam, I want to thank you as always. It's just was incredible session.
Thanks so much, Aaron. You're always great to me, and I can't tell you how much I appreciate being able to work with Eva on this.
Awesome. Thanks, everyone.